Beast Academy 3A, the guide, more about shapes in chapter 1. This is Woodshop Triangles. Avast, me hearties, behold the triangle. Every triangle be having 3 magnificent sides and 3 glorious angles. 'Tis the strongest of all the polygons. What makes a triangle so strong? The triangle will not collapse without bending one of its sides. Allow me to demonstrate. If I assemble 4 planks to make a square, 'tis a frail, flimsy, wobbly thing. But assemble 3 planks to make a triangle, and you got yourself a mighty figure, stout, sturdy, robust. What could be making a square stronger? Weightlifting. Could you brace it? Connect another piece of wood between 2 corners. Aye, we add a brace, and what does the brace do to our wobbly square? It splits the square into 2 triangles. Aye, and the only thing better than 1 triangle is 2 triangles. What things be using triangles to make them stronger? Bicycles, bridges, houses, my tooth. The brace be splitting the square into 2 right triangles. In a right triangle, one of the 3 angles be a right angle. What do we call a triangle with 2 right angles? I don't think that a triangle can have 2 right angles. If a triangle has 2 right angles, 2 of the sides can't touch. No triangle can have more than 1 right angle, but a triangle can have 3 acute angles. We call it acute triangle. Aye, 'tis an acute triangle if all 3 of its angles be acute. If all 3 angles are obtuse, is it an obtuse triangle? There's a stop sign. Can you draw a triangle with 3 obtuse angles? That stop sign has 8 of them, right? So maybe a triangle can have 3 of them. Give it a try. Pause the video for a second. Get a piece of paper and a pencil and try drawing 3 acute angles. 3 obtuse angles, and see if you can make the ends pair up. No triangle can have more than 1 angle that is obtuse. But any triangle that has 1 obtuse angle can be called an obtuse triangle. So if all 3 angles are acute, then it's an acute triangle. But if just 1 angle is right, then it's a right triangle. And if 1 angle is obtuse, it is an obtuse triangle. You've got it. Isn't there another way to describe triangles? Aye, there be 2 ways to describe a triangle, by its angles and by its sides. If all 3 sides be the same size, 'tis an equilateral triangle. There's a box at the bottom that says, here's some more information. Equilateral means equal-sided. Any shape in which all sides are equal is called equilateral. Lateral, sided, equal, equal. For example, all squares are equilateral because all 4 sides of a square are the same length. Stop sign says, are all equilateral triangles acute? Can you draw more than 1 equilateral triangle? Maybe you can. Maybe make it bigger or make it smaller. But is it still equilateral? And if it's equilateral, is it still acute? Something to think about. Every equilateral triangle be having 3 equal acute angles. So every equilateral triangle be acute. If 2 or more sides be equal, then you be calling it an isosceles triangle. Isosceles. This isosceles triangle be acute. And when, oh, there's a stop sign, hold on. Can you draw an isosceles triangle that is right? Can it be both isosceles and right? I bet it can. Can you draw an isosceles triangle that is obtuse? I bet you can. Obtuse, one obtuse angle and 2 very thin acute angles. If my hands are both the same length, my thumbs don't quite reach, but if my hands are both the same length to my thumbs, then it's still isosceles, even though it's obtuse. And then I make it a little more and it's more like right. And then I make it a little bit steeper and now it's acute again. Here be examples of all the different types of, oh, I skipped this panel, I'm sorry. And when no sides be the same length, 'tis a scalene triangle. Scalene. This be a scalene right triangle. Here be examples of all the different types of triangles. So you've got the different types of sides on the left, the equilateral, the isosceles, and the scalene, and the different ways to categorize it by angles on the top, the acute, the right, and the obtuse. But like we talked about, an equilateral triangle is always going to be acute. There's no way to connect 3 of the same length sticks and have them meet in any way other than at acute angles. That's the only triangle I can make with these 3 same length pins. So, why do we need to learn all of these words for different kinds of triangles? Let's play a game, Winnie. Come up to the front. I'll give you a card with a drawing at the top. You try describing it to the class so they can draw it. But there be a catch. You can't use any of the words on the card to describe it. Sounds fun. I'll try. Let's see. It has 1 short line, 1 medium line, and 1 long line. The part where the short and the medium lines come together at a corner is like, it's really big. It's the letter K. No. Is it a cost volume profit analysis? Ugh, no, it's not one of those. It's Tyrannosaurus. Do you know what Winnie is describing? Let's read it again. 1 short line, 1 medium line, and 1 long line. So 3 different length sides or lines. The part where the short and the medium lines come together at a corner is really big. What do we call the really big one? No, it's a scalene obtuse triangle. Scalene, 3 different sides. Obtuse, really big angle, right? Wouldn't it have been easier to just give it a name? Oh, that's easy. Yeah, why didn't you just say so? Those were the words I couldn't use. Words can be coming in handy when describing a thing. 'Tis much easier to say scalene obtuse triangle than to say a closed shape with 3 sides that are all different lengths and with 1 angle that is open wider than a perfect L. Anyone else want to try a card? I'll try. Okay, this is a flexible pulmonary suction powered pressure differential liquid transport cylinder. I know, it's a bendy straw. That was pretty funny. Flexible, right? It bends. Pulmonary suction powered, so using your lungs to suck, and that's what moves the pressure differential liquid that it transports up the straw. Pretty fun stuff. All right, I'm gonna leave you with this recess activity. So have fun, give it a try. If you can't read the instructions, I'll read them right now, but otherwise we're done for the read aloud. Instructions: draw from 5 to 8 dots connected on a loop as shown. Players take turns connecting 2 dots with a straight line. The goal is to avoid connecting a pair of dots that completes a triangle. So avoid making triangles. The game ends when one player completes a triangle. Important, triangles only count if all 3 corners are on the dots. So you can make little triangles where lines crisscross, like in player 1 here, but you can't make a triangle out of 3 dots. So try it with various numbers on a circle, and then a variation begins with 6, 10, or 15 dots arranged in triangles. 6, 10, and 15 are triangle numbers. Players take turns connecting a pair of neighboring dots. As before, the goal is to avoid connecting a pair of dots that completes a triangle of any size. So there's an example there. Good luck, have fun. Chapter 1, Shapes of Book 3A, Beast Academy, will continue in the next video.